You will learn about OpnSense Firewall, how to install it and use it in Azure in order to secure your resources. Open Source Firewall is an open source project available within GitHub. It's a fork of pfSense, which is a fork from another firewall which is called MonoWall. OpenSense is mainly a firewall that can log and filter the traffic. It requires FreeBSD to be installed, and it comes with a UI dashboard which makes it easier manage it and also define the rules. OpenSense comes with a rich set of features that includes support for VPN connectivity with point to site and site to site. That includes technologies like WireGuard and OpenVPN. It comes also with support for multiple DNS servers like OpenDNS and Unbound DNS. And OpenSense can also manage multiple networks that could be different LANs and WANs. OpenSense have also built-in integration with forward proxy like Squid proxy, and it have intrusion detection feature that could be enabled. And to add to these features, OpenSense supports multiple official and community plugins that enables integration with other third-party providers. Follow me in the next demonstration to see how we can install OpenSense into an Azure virtual machine. You will learn how to install OpenSense into an Azure virtual machine. OpenSense requires FreeBSD as an operating system, and for the install, we're going to use a shell script that will apply an XML configuration file that will describe the configuration of the OpenSense. For a quick install, we'll go to rely on Terraform configuration files in order to provide all the resources required by OpenSense. And you can find that template or that demonstration within this GitHub repository under the folder number 205 for MVA OpenSense. And by the way, within the same page, you will find also all the instructions required in order to deploy this infrastructure. So let's see how that works. So here I'll go to switch to my VS Code where I have already cloned that Git repository into my machine. And here I have that same Terraform code. Let's start by analyzing that Terraform code. So mainly here, this Terraform code will go to use Azure RM provider in order to create the resources. So here, first of all, we create a new resource group. We give it a name, a location, and then we create a virtual network. That VNet will be called VNet Hub. It would have two subnets, one for untrusted and another subnet trusted. The trusted subnet will be used for the internal traffic, the traffic between the different spokes, and the untrusted subnet will be used to expose the firewall into the internet through public IP. And then because we will go to deploy a VM, we also create here an NSG network security group, and then we attach it to the untrusted subnet. And within that NSG, we just open the all inbound and outbound traffic. It's not required to open it all. But for the simplicity of this demonstration, I just did. And then next here, we are ready now to deploy the OpenSense firewall. So we basically create a virtual machine with the public IP address and a network interface. And here, because we are using two subnets, trusted and untrusted, we also create two network interfaces, one for untrusted and another one for the trusted traffic. And for both of them, we enable the IP forwarding enabled. This what will enable the traffic between different spokes to go through the virtual machine of OpenSense. If we don't enable this one, then the traffic will not go through OpenSense. And then next we create the virtual machine, and because OpenSense requires FreeBSD, so we specify within the source image that what we want to create here is a VM with FreeBSD OS image. And here we have the configuration for that with the version and so. And then I choose here the size of that VM. Here I've chosen D4ADS V6 with a spot instance that uses NVMe disk for better disk performance. And then I specify an admin and password for my virtual machine. So this will go just to create the virtual machine with FreeBSD. Until now, OpenSense is not installed yet. So we'll go to install it through virtual machine extension. So we create a resource of type Azure RM virtual machine extension, and then we provide here within the settings section the command to execute. And here we tell it to run shell and run this shell script, which we leave within this GitHub repository. which is mine actually, and that's because within this scripts folder here I've specified the two configuration files. The first one is the shell script that will go to install or download actually the shell script from OpenSense, and then it will go to make some changes to that script, and then it will go to install it into the Azure virtual machine, and it will apply the config.xml file which describes actually the configuration of the OpenSense firewall. How I've extracted this config XML file, actually at first I've created the OpenSense firewall manually, I've configured it as I want, and then I went just to export this XML file. So then I can reuse it later to create a new instance of OpenSense with the same configuration. So you note that here there are some parameters that we pass to this shell script, and those parameters are specified right here. So we specify the path for the shell script, which is the GitHub repository, and then we specify here the version, the gateway IP, and the public IP address of the OpenSense, and we get those values as local variables within Terraform. So as per today, we are using OpenSense version 25.7 because that's the latest one available as per the recording date. But in the future, I believe there will be newer versions, so check always for that. Okay, so then next we go to Terraform and we go to apply this Terraform template by running the command terraform apply -auto approve, and that's what I've done. So here Terraform scanned my Terraform templates and then deployed the resources, and then shows me here the output of those different resources. So this means that my resources were deployed successfully. So here if I navigate to the resource group of OpenSense right here, then I should see those different resources. So I see here the Azure virtual machine, the VNet, the NSG, the two network interfaces, and the NAT gateway with the public IP. So now if I select the Azure virtual machine, I should see here the primary network interface public IP address. So I'll go to copy that IP, and then I'll go to paste it into my browser right here, and that will open access to the dashboard of OpenSense. Note that here tells me that the connection is not secure. Yes, because we didn't configure TLS certificate for that. So in this case, I'll go to accept this. So I click on advanced, and then I click proceed to that unsafe IP address. And here we get the login page for OpenSense. So here I'll specify the login and password. The login is by default root, and the password is OpenSense, all lowercase. And then I go to click login. And here I get access to the OpenSense dashboard that is installed within an Azure virtual machine. And from this dashboard, you can see some traffic happening on that VM. You can also view in the reporting section some of the reporting that could happen right here. Within system, you can see the configuration, check if there is some updates. And then within firewall, you can check here the firewall rules for the LAN, for the WAN, and for the VPNs. And within the VPN section here, you can configure a VPN connection like OpenVPN, WireGuard, or through IPsec. And within the services section right here, you can configure a DNS server like OpenDNS or Unbound DNS. Follow me in the next video to see how we can establish a VPN connection through WireGuard to this OpnSense. In this video demonstration, we'll learn how to use WireGuard to establish a VPN connection to the OpenSense firewall. We will have OpenSense already running within an Azure virtual machine, and it will be configured to enable WireGuard VPN through the config.xml file that describes all the configuration for the features of OpenSense. One of them is WireGuard VPN, and then we'll simulate from a virtual machine that could be your machine, or in our case it's going to be an Azure virtual machine. We'll go to install WireGuard on that virtual machine, and then we'll generate a configuration for WireGuard connection, and we'll use it in order to establish connectivity to the OpenSense that runs a WireGuard server within the VM. Let's see how that works. So here again, I'll be reusing the GitHub repository from the Azure Network course, the folder number 205 that contains all the Terraform files. And it contains also the config.xml file that describes the configuration of the OpnSense firewall. And by default here, it will actually enable WireGuard instance, and it provides all the configuration required in order to enable WireGuard. That means that here within the OpnSense FireGuard, or the OpnSense firewall, if I navigate to the VPN, I should see here WireGuard, and then I can go to the instances to see here that I have some instances available. And within interfaces, I can also see a WireGuard instance or interface that was configured by that XML file. So it's ready to use, and I just here need to generate a VPN client configuration and then use it from a VM to connect to WireGuard. And to do that, I'll go to either the peers right here, or simply I can just navigate to the peer generator, which will help me here to generate WireGuard configuration that I can import into my virtual machine to connect. So here we have some information about that connection that are pre-filled. So first of all, we should select the instance, and in our case here it's going to be WireGuard instance, and then we select the endpoint, that's the public IP address of the virtual machine with the port number used by WireGuard, which is 51820. And then we need to provide a name for this connection. Let's say that's Azure VPN client, for example. And then you should see that the public key actually will be generated automatically along with the private key. And then here we put the address that will be assigned to the connection. Once we connect through the VPN tunnel, at the VM level, we see the connection coming from this IP address 172. And then within the allowed IPs right here, we can specify a list of allowed or denied IPs. In this case, I'll allow for all IPs in V4 and also all IPs from V6 ranges. And then as OpnSense Firewall comes with the feature that can enable DNS servers, actually we have also enabled a DNS server by using that config.xml file, and thus I can here use the DNS server that is configured within the OpnSense virtual machine. So here I just specify the DNS server IP address, which is in my case here the same IP address of the virtual machine. I can add .53, which is the default port number for DNS servers, but by default it's gonna be .53, so I don't need to add it right here. Once all those configuration is done right here, it will generate to me here this configuration file. So I just need to select it all and then copy that configuration, and then don't forget to go to store and generate next, this tick right here. And note here actually generated another configuration. So if you didn't copy the previous one, then you can still copy this newest one and then click again store and generate next. And after that, you need to click apply, so that configuration will be applied to the OpnSense firewall. Great. Now let's take this WireGuard configuration and test it within an Azure virtual machine. And to do that, note that here within my Terraform code, I have already this Terraform file, VPN client VM Windows 11, and this will create an Azure virtual machine within its own virtual network and within its own resource group. It would have an NSG rule that will allow all inbound and outbound, and then this virtual machine will be of type Windows 11. And when I deployed my Terraform code, actually that VM also were deployed along with my code. So here, if I navigate back to my Azure portal and then look for the resource groups, I should see the second resource group, RG VPN client 205. And then if I navigate there, go to the VM. From here, I go to grab the public IP address of that VM, and then I go to use RDP in order to connect to that virtual machine. I'll do that using the command line, using the command mstsc, then /f to say I want to launch the RDP client in full screen mode, and then I'll add -v, and then I'll paste the IP address of that VM. Then I click enter, and here I get asked to provide the username and password to access that VM. The username is Azure user, and the password is the one available within the Terraform code, which is this value right here. So I'll copy it, and then I'll go to paste it right here, and then I click OK. RDP asking for my permissions, yes. And here we can see the VM starting. I'll go to hit accept. Now that I've get access to my VM, here I need to first install WireGuard client into this virtual machine. I'll do that using the command line. So I'll use actually winget, the easiest way to install WireGuard. I'll go to run this command that is available within the README file from the Git repository. So winget install and then --id wireguard.wireguard. It's as simple as that. I'll run it. So it will go to download the WireGuard MSI file and then install it into the VM. So per now we should have WireGuard already installed into that VM. If I search WireGuard here, I can see it. So I launch WireGuard, and here for now it's empty, does not have any file. So I'll go to click add tunnel and I'll choose here add empty tunnel. I'll give it a name like Azure client, for example. And then here I go to paste the configuration that I've copied from OpnSense, which is this config right here. And here, if you are running on Azure virtual machine, make sure to uncheck this box right here, block untunneled traffic. Otherwise, you will lose access to the Azure virtual machine. So I'll uncheck it and then I go to click save. And note here how WireGuard have took this configuration. And now I need just to go to activate this connectivity through the VPN tunnel. And here you can see that the transfer will happen successfully. And we can see that some of the first bytes are uploading or are downloaded from the OpnSense Firewall. Great, we can start it and stop it at any time. So here I go just to deactivate it and then I'll go back to the command line right here and I'll go to run the command curl ifconfig.me/ip, where here we'll be able to view actually the IP address that is used by the VM in order to connect to the internet, to the site ifconfig.me. And we can see that public IP, which is here the public IP address of this Azure virtual machine. And we can verify that actually. So that IP is 135 and then .100. If we go to the Azure portal, yes, that's the same IP used by the Azure virtual machine, which is acting as the VPN client. Now, if I go back to the VM and enable or activate the VPN connection and then run again the curl ifconf.me, then here we can see actually another IP address, which is .73. We can go back to the Azure portal and check which IP address is that. If we go back to the hub resource group, and then if we navigate to the prefix for the NAT gateway, here actually we have created the NAT gateway in order to provide outbound connectivity to the internet from the OpnSense firewall. So here we can see that we have actually an IP prefix which is 135.116.22.72/30. Means we have 4 IP addresses that will be used for the outbound traffic, and .73 is one of these IPs that will provide the outbound connectivity to the internet. Great, so all the traffic here going to the internet from this VPN client actually will go through the OpnSense firewall. Follow me in the next demonstration where we'll see how we can use OpnSense Firewall in a hub and spoke architecture. In this demonstration, you will learn how to use OpnSense Firewall within a hub and spoke topology. We would have a hub virtual network. Within that virtual network, we would have the OpnSense Azure virtual machine, and then we would have 2 spoke virtual networks that are VNet paired with the hub network. And then we'll test that both VMs within the 2 spokes can communicate with each other through the OpnSense Firewall. And then we'll go to try to block that traffic from VM1 to VM2 and allow the traffic from VM2 to VM1. So to create the resources in this architecture, we rely again on Terraform. And the Terraform templates could be found within this GitHub repository, Azure Network Course, the folder number 207. Those are the same Terraform code that you can see right here in my VS Code. I have cloned that Git repository. And here I can see the different resources that will be deployed. Mainly we would have our NVA OpenSense, which will be deployed within the hub virtual network. It will be deployed on FreeBSD OS, and it will be deployed through the virtual machine extension, which will run the shell script that is available within the scripts folder, which is this file right here. And it will use the config.xml file that will contain the configuration of the OpenSense. And there are lots of default configurations here in this OpenSense, like it allows, for example, for communication between all the spokes that are paired with the OpenSense. And then we deploy an Azure Bastion in order to allow for simple access to the virtual machines. And then we create actually two spoke networks. Each one is paired with the hub network. And within each spoke, we create actually a virtual machine using a module here. So we have two VMs. We use two modules, and within each module or within each VM, actually we expose a sample Nginx application that will be installed through the script install webapp.sh. And that script actually will go just install Nginx and change it in order to show, instead of the default index.html file, it will show actually the private IP address of the virtual machine and its name. And of course, within each spoke, there is a route table that will go to route all the traffic to the virtual appliance, which is actually the OpnSense Firewall. To deploy these resources, we use the command terraform apply auto approve, and then terraform will do its magic, and then it will define all the resources, and then it will go to deploy them one by one to our Azure subscription. That's what I've done earlier before starting this demonstration. So now if I switch back to my Azure subscription and look for the resource groups, I can see that there are 3 new resource groups were created for the folder 207. One of them is the MVA for open source, and this will host actually the virtual machine that will be used by OpenSense Firewall. And you'll find also the Bastion host and a Jambox VM if you want to make some tests to that connectivity. And then the two other resource groups are for the two spokes. So for spoke 1, or for each spoke, actually we would find a virtual machine, a virtual network that is peering with the hub. So if I navigate to the peering section, you can see the peering with the hub here in both directions. And we see also a route table that is configured with a route for all the traffic to be routed to the virtual appliance, which is here the private IP address of the OpenSense firewall, and that will be applied to the subnet of the spoke virtual machine. Great. So now if I go to one of these VMs right here, actually I'll open them both. Let's now navigate to the second one, open it again. And because we are using Azure Bastion, so I can connect to both of these VMs via Bastion. So I select that option, and then I fill right here the username and the password for each VM, which are in my case here Azure user, and the password should be this value displayed right here for each virtual machine. So I select that, and then I click connect, and that will open a new window in my browser. Good. So here I get displayed with the private IP address of this virtual machine, but I can also do curl for that IP address. I can curl the localhost or the private IP address of this VM, and both will give the same result. That will show me this message coming from the Nginx app that shows me the name of the current virtual machine and also the IP address. Let's now take this IP address and let's try to communicate to that IP address from the other virtual machine, that second virtual machine. So I'll connect to that second virtual machine using Bastion. So I specify username and password, and then through Bastion I'll be able to access the VM. We see its private IP address right here. So in its turn, it will show us actually that message, but displaying the name of the second virtual machine. Now let's try to go curl the IP address of the first virtual machine, which is the address 10.1.0.4, and yes, here we get connectivity. So the second VM can communicate with the first VM. Let's try from the first VM. If we do curl for 10.0.0.4, And yes, the first VM also can communicate with that second virtual machine. So the communication here is happening bidirectional from VM1 to VM2 and from VM2 to VM1, and it traverses the OpnSense firewall. And because within the firewall we have enabled logging the traffic, we can actually view that traffic within the OpnSense. So if I navigate right here to the dashboard of the OpnSense and then go to the firewall, then log files, then select right here live view, we can see here all the traffic going through the firewall, and within the source IP address right here we should be able to identify our VM. So here I go just to disable auto refresh, and then I'll try to locate the IP address of my private of my virtual machine, which is 10.1 10.1.0.4. Here we can see all the traffic originated from from our first virtual machine to the second virtual machine, and as you see, all the traffic is allowed. Okay, now what if we want to block this traffic between VM1 to VM? So to do that, we can check here the firewall rules within the rules section. If we navigate to the one section right here, we can view here we have actually rules that will allow all the in and out traffic to the one. But you can also do is to create a new firewall rule that will block the traffic in the direction of VM1 to VM2. So here I can go to create a new firewall rule, but within the action, instead of specifying pass, I'll specify here a block. The interface will still 1, and the direction is in. It will be applied for IPv4 traffic, and then for the protocol for any protocol actually. And then for the source, we'll use single host or network, so that we can specify right here the side range for my spoke 1 subnet, which is in my case 10.1.0.0/16. That's actually the side range you can see from within the virtual network for the spoke 1, 10.1/0.0016. And then for the destination, I'll block based on single host or network, and then I'll specify the side range of the second virtual network, which is 2.0.0/16. Great, I'm okay with this config. I can actually go to log the packets if I want, and then I click save. Once it's saved, you can see it added right here with the icon disabled. Great, now I want to give more priority to my rule. So for that, I'll go to select it right here, and then I'll go to click on the left arrow icon right here for of the first rule, which will let my rule right here be the first rule available here. And then I'll go to apply the changes, so that now I can go back to my VM1, which used to connect to VM2, and try again that connectivity. And yes, right now we can see it's delayed and VM1 cannot anymore communicate with VM number 2. The connection here actually it will be timed out in a few seconds. However, from VM2 actually, if I try again to connect to VM1, I still be able to connect because I didn't block the traffic of from the direction of VM1 to VM2, or from VM2 to VM1. Great, so that was how to use OpenSense Firewall within a hub and spoke topology. Follow me in the next demonstration where we'll add to this topology a VPN client connectivity from an Azure virtual machine that will try to connect to applications exposed by both Azure virtual machines. Let's learn in this demonstration number 4 how to use OpenSense and a hub and spoke topology and a VPN connected machine. In the previous video, we have already set up the hub and spoke topology architecture right here with the OpenSense hub virtual machine and the two spoke networks. And today we'll go to add this VM right here that will act as the VPN client that uses WireGuard in order to connect to that client VPN machine is actually this VM right here described with this Terraform code. It's at the end a Windows virtual machine. It's not connected to the network of the hub and spoke at all, but the connection will be established through the VPN tunnel. So now when I navigate to the Azure portal, I will see here the resource group that will host my VPN client. If I navigate there, then I should see here my virtual machine with its public IP, its network, NSG, and network interface card. I'll go navigate to that virtual machine, and then I'll get its public IP address, and then I'll use it to connect with the RDP. Once I'm connected to that machine, I started here the terminal, and then I've run the command right here winget install in order to install WireGuard. Once WireGuard is installed, here it's ready now to accept a configuration file to allow access to the WireGuard server. And that's what we are gonna do here through the OpenSense dashboard, where here we go to navigate to the VPN section, select WireGuard, and then select peer generator, and then we go to make sure that the IP address right here matches the one for the WireGuard server. Let's put this IP address right here. Let's change that. And then we specify public key and the private key. Those could be auto-generated by WireGuard. And then we specify the address that will be used to connect. The allowed IP addresses we open for all IPs. And then for the DNS server, the same. So we should specify the IP address of the VM hosting OpenSense, because here on my OpenSense I have actually the DNS server is already enabled by default. So then this WireGuard configuration will be generated for me. So I'll copy it, make sure copy it before storing it and generating next, and then I'll do here store and generate next, and then I'll go to apply that configuration. After that, I'll go back to my VM right here, and then I'll go to give a name to this connection. Let's say VPN client, for example, and then I go to delete this default config, and I'll go to paste the one that I've come OpenSense, and then I go to make sure that I uncheck the block untunneled traffic. That's the kill switch feature, and then I go to save the configuration, and then I activate my connection through the tunnel. Once that's done, and it seems that it didn't receive any traffic, so this means something not working. So I'll go just to go back to the user interface, and yes, I know why, because here I didn't specify a name for that connection. Let's call it again VPN client, for example. So because it didn't provide a name, it didn't save this config right here, and it generated a new one. So I'll just go to copy this new config, click save, generate next, and then apply the configuration. And then from my Azure VM, I go back here, deactivate that connection, hit edit, and then I replace this old config with the new one, uncheck a block, save, activate, and yes, now it works very well. So now this VM right here will be able to go to the internet through the VPN tunnel, and from there through the public IP address of the OpenSense firewall. So if I try here curl if config.me/IP, I should see here the same IP address of the firewall, which is here 90.190, exactly the one right here. And even the DNS resolution will happen actually through that IP address. So if I try to resolve config.me through using ns lookup, we should see here actually it will use, by default, it will use the one configured for the VM, but I can actually force it to go through the DNS server within the firewall, and yes, that works, right? Great. So now we have a VPN client virtual machine that is connected to the hub virtual network. It means that through that connectivity, it can also connect to the Azure virtual machine in Spoke 1 and also in Spoke 2. Let's verify that connectivity. We know that VM in Spoke 1 have this IP address 10.104. I'll go to my VM and I'll try to curl that IP, make it a little bit bigger, so it's 10.104, and yes, here we get 200 OK response, and here we get the message coming from that virtual machine from the spoke number 1. Let's try to connect now to the spoke number 2, 10.204, and yes, we get also 200 OK response with a response coming from the VM spoke number. And that was how to allow a VPN client machine right here to connect to the different spokes through the hub firewall. I hope it was helpful. Thank you.